India. Welcome to today's webinar on Enter the Brave New World of Gen AI with Vector Search by Mary Grygleski. I'm Mishika and I'll be your host for today. This webinar is brought to you by E2E Networks Limited, India's leading cloud GPU provider. Today, we are in for an exciting session as we delve into the concepts of artificial intelligence, focusing on generative AI, ChatGPT, large language modules, natural language processing, vector DB, vector search, and the operational concerns in managing machine learning environments. It's my great pleasure to introduce you to our esteemed speaker, Mary Grygleski. She is not only a Java champion, but also a developer advocate at DataStax, where she specializes in real-time AI, big data, DB as a service, streaming, and a cloud-native system. With over 25 years of hands-on experience in software engineering and technical architecture, Mary's journey into developer advocacy began in 2018 in IBM. Her passion lies in reaching out to developers and empowering them to excel in their craft. Beyond her professional endeavors, Mary is a cornerstone of the tech community, actively involved as the president of the Chicago Java Users Group, where she fosters collaboration and growth among fellow enthusiasts. Please join me in welcoming Mary as she shares her insights in the ever-evolving landscapes of technology and developer advocacy. So, Mary, over to you.
Thank you so much, Mishika. Thank you for the nice, warm welcome. So I won't spend too much time introducing myself anymore. So welcome to everyone who is here today, or if you're watching the recording too, so thank you. And thanks again to Jibin for having invited me and the E2E Networks company for hosting. So I'll share my screen. Let me do that and here. Okay, so you can see my screen right now. Okay, let me gotta move it.
Yes.
Okay, great. Yeah. So I will be talking about, enter the brave new world of Gen AI with vector search. So as such too, as you know, Brave New World is actually, I borrowed this title from a book, by Aldous Huxley, right, about Brave New World. It's also about technology. However, in the book too, I think it describes technology as being problematic too, and all these things. So, but hopefully too, I think with generative AI, right, and I think I'm seeing potential. To me, there are people that may be kind of like being critical about it. They said, oh, it's just another kind of like fad, but as I'm working more and more into it, I don't think it will be like a temporary thing, not like some people are saying, say, blockchain or cryptocurrency like that, but I think it has much far more usages, even though it's not truly mature yet, right? So that's what I'm going to get into. So again, welcome to my talk, and let me go over there and swip the thing. So let me then give you a quick agenda for what I'll be talking about right now. I won't actually introduce myself now that Mishika did a great job, but I'll jump straight to giving you a brief background of AI, and I'm just kind of assuming maybe not everybody is familiar with it yet. You are all specialists in your own area, but maybe specifically AI could be new to you. So I hope to bring this talk as sort of an introductory materials for all of you. And then I'll get into, what are the players, in this generative AI era. And then I'll talk, a couple of these terminologies that are popular: GPTs, LLMs, NLP, all of these things. And then also kind of have an emphasis on vector database, vector search, why are they important? And then we'll give you a quick demo. In today's case, using specific like DataStax as the Astra database serverless with vector. And I'll then close the session on discussing some benefits and also like challenges of this field to you, and then sharing with you the resources. So first of all, who's Mary? I won't spend much time, but I'm actually a kind of technology enthusiast too. I like talking about it now. I started talking, six years ago as a developer advocate, and I'm enjoying it every day. And I'll be sharing with you my links and my contact information towards the end of this presentation. So let me then start, right? A brief background of AI, right? So for me, I have to say too, how I got into AI too is kind of interesting, because when I was at IBM, I actually had some exposure. Obviously, IBM has been a company full of all kinds of technology, and I was also close to the AI team at the time, machine learning. So I did a little bit of AI and machine learning. That was back in 2019 to 2020. But as such, too, that was before the times of GenAI. Then all of a sudden, GenAI came into being, and we were all excited about it. So why, right? But let's take a look too first, into some history about it too. Actually, I think I might have skipped a slide. Let me get into here first. So as I'm kind of understanding, I think all of us thinking that, okay, AI is all the machine, all of these things that are in near terms, right, about robots, all of these. However, strictly speaking too, as I started doing my research, because DataStax was wanting everybody, to kind of turn to doing GenAI, from a database Cassandra company, now turning more to generative AI. Then I kind of started looking into this too for AI. I wanted to know. So there's actually on record too, is basically saying that, if you kind of strictly kind of counting the beginning days of AI, artificial intelligence, it should be counted, in the year before Christ, right? BC, 400 to 500 BC, like here with these steam-powered pigeons. And it was designed and, kind of made by this Greek philosopher called Archytas in there. And this is the source where I got it from. So essentially, why is it so, right? They aren't really artificial, but I think artificial in the sense is that these are like, flying pigeons that did not require human beings to make them fly. These are artificial ones, but artificial was being powered by steam. So it's mechanical, but still is kind of considered, part of like, kind of like automation. And that's what it's all about, AI. Essentially, too, we've kind of looked into the near old times, about 100 years back, is that's when the present day and age of artificial intelligence started. And basically, science fiction, it was kind of beginning with more of these things of humankind, through literature, through writing, examine this, kind of aspect of human lives in which, we're talking about, can machines think? Can machine really think? It was basically asked in 1950 by the father of modern computing, Alan Turing, right? Can machines think? And that's when kind of like the golden age, of all of these activities started and pushing the real, kind of artificial intelligence to the present age in the digital kind of space, So as it kind of goes through time, I won't step through all of it now. If you're interested, I give the link in here where I draw this graph from. I just thought it was kind of nice to kind of highlight, the history of, how AI has been developing. And if you kind of look to over here, the artificial intelligence, this blue line is what is describing, right, the artificial side of it. But I think I like to highlight too, since I work for IBM, in 1997, it was Deep Blue, which was developed by IBM, and it was kind of specifically developed to play chess. And at the time, it defeats like Garry Kasparov, who was the, kind of like human champion in chess at that time. So that was kind of some interesting history. But as you can see, all of these other things that were happening at the time, they were kind of all essentially propelling, the push of artificial intelligence forward to where we are today. But of course, there are, kind of many steps too that kind of goes through all of it. So I just found it to be interesting. And as such, AI is really all about automation, so then human beings don't need to actually be doing as much. We're letting machines do the work, but most important too, the intelligence part is to get machines to think, so that we don't even need to think, kind of like that. Now, the thing is too, is that with AI, some of you may already have, be aware of this particular kind of high-level description of AI and machine learning and deep learning. So it's much like AI is like the outer layer in which is describing, an activity, a branch of study that mimic the intelligence or behavior pattern of human beings or any other living entity. And then as you kind of like close in on it, AI is still a bit more abstract to this term, but if you kind of hone in, it becomes like more specific. And so it gets into like machine learning. Machine learning involves a technique in which the computer can learn from the data. There's no need for us to explicitly like teach it, so to speak, right? So it can be like supervised learning or unsupervised learning, all of these, but essentially too, it's just from data. We want the machine to start to learn by looking at the data itself. Now, however, if it's just like kind of machine learning, as we know, it's not really sufficient, because what is really required of the intelligence is really getting into, how the human brains work. It's basically a study about how neural networks. That's the layer. So that's deep learning. That's where all the magic is happening. That's where all of the current, LLMs, which I'll be talking about shortly. That's where, it is, it belongs to. If you kind of conceptually looking at this picture, is deep learning is where, technique is to perform machine learning, and that's inspired by our brains, like neural, network of neurons, essentially. So now then, let's take a look at this fascinating era, of Gen AI. So what is Gen AI? It's basically a very disruptive field in AI. And why is it we call disruptive? What makes it kind of really standing out, So essentially, it has the potential to change the way how we create and consume content. Now, the big difference is that now there's no need for us to always follow any strict rule when we need the machine to do our work. It's, as we know, some of us, are developers, or most of us here could be developers, right? Or even if you're doing infrastructure work too, you will need to still have script, that kind of essentially guide what must be done. And then it's sort of strict rule, because you can be running a script and then basically passing in parameters to tell the machines what to do, that type of stuff. And so it's pretty machine centric, right? But the thing is with Gen AI is that now you can ask the machine to do work for you and just talk to the machine like you're talking to another person. So that's the disruptive part, and it's not very easy to do, we're talking like this. How can we make machines know, right? There are a lot of nuances too. So essentially, Gen AI uses a combination of the machine learning and the deep learning that I just pointed out to you. It's essentially a combination of these techniques to produce the output, to produce contents. And then Gen AI too tends to be more creative, the kind of content, right? Now, as we all know, it can write a song, it can write an essay, it can design a dress, all these things, and write code. Those things are very kind of innovative in that sense, right? So and also too, what it produces is more long lasting. In a sense, it's more kind of creative and is not bound by time. Because right before Gen AI, it was predictive AI. Predictive AI is pretty much has to look at the data and make predictions and doing analysis, and then kind of looking at the previous data and then predict what it is, in the future, kind of like that. And also has a time limit, much like, for example, weather forecasts, sales forecasts, and business forecasts. All of these tend to have a time validity to it. You can say, forecast this business for me for the next year based on past performance, like that. Whereas, with creative generative AI, there's no time limit. You just write an essay, it can last forever, for example. Okay, so now let's understand then, when this Gen AI really started, happening, right? I showed you history earlier. So if you kind of look back, it's roughly 20 years ago in 2003, when the first feed-forward neural network got developed by Joshua Bengio at that time. And then, of course, then in 2011, I think that's most, kind of well-known, was Apple has its own Siri with the iPhone, right? So that actually makes use of NLP, essentially natural language processing. It brought, this NLP assistance to the masses. If you're using iPhone, you already have Siri. That was like, 13 years ago, right? Now is 2024. Back then was 2011. And then as that is starting to come out, we're seeing more and more research. 2013, for example, is word2vec, and that's pretty much the vector search, sort of like started in that time frame. The word2vec is an early form of vector search, because it's basically using techniques, to train and uses, neural networks to learn word associations from a large, set of text, essentially. And then 2017, the transformer, there was a paper written about it. And if you're familiar with it, you might have heard of this phrase, attention is all you need. And that's what, they're like proposing from Google, this new simple network architecture called the transformer. And that was in 2017. So it's just, kind of quite recent too, like 6 or 7 years ago. Okay, so now with this understanding, let's move on to the next part, which is let's understand, some of the new players, in this generative AI era. So by players, what I really am talking about is essentially, all these things that pop up, and first and foremost, generative models, right? So all of these two essentially, requires pre-training in machine learning. As we know, you need to pre-train based on the data set. You need to train the model, and essentially too, these models, it kind of depends on, it's basically drawn from a huge, they call it corpora of text, right? Of all these information it needs to crunch through. So all of these two basically get trained and became the models. And first and foremost, and most famous one, basically is GPT 3.5, from OpenAI. And so, as such too, GPT 3.5 is disruptive, came out in 2022 November, so slightly a year or so ago, a year and 3-4 months, right? And that's very disruptive. And then there's GPT-4 that's kind of updated, other versions too in the spring of last year. And then, of course, too, there are other models such as BERT. I want to point out BERT is actually a very early form of LLMs, large language models, that came out of Google too. And then there are variants too of various BERT model after that. And then, of course, there are also image, to text to image from Stability AI, Stable Diffusion, Dolly, Midjourney. All of these are more like, kind of image, dealing with image type of models. And then there's also Llama 2 from Meta or the Facebook, right? And Codex that came out is actually more for code generation, for Copilot, for example, is dependent on that. And then Google too has Gemini, which is a multimodal type of model. And then Whisper is also like AWS with audio type of kind of data too. So these are example, right? It's not all of it. There are actually more models too, but these are quite the famous one. And of course, OpenAI is essentially the de facto kind of organization that has, kind of a lot of these models that it governs or kind of manages, so to speak. And now, after looking at the models, let's take a look at some of the apps. While the apps too, there are infinite number of them now. But again, these are just kind of couple of examples. And I've already pointed out, for example, GitHub Copilot, that's dependent on the Codex model on it too. And that's a generative app. And then there's ChatGPT, essentially is built using GPT 3.5, right? ChatGPT that came out. That's the kind of really famous one, right? And then there's also other kind of BART, that came out of Google, and then Bing from Microsoft, for example. And then the other ones like Salesforce AI, Notion AI, SEO AI, all of these, that's kind of coming from different companies that they are actually generative apps that makes use of the models to do all of these AI type of applications in there. And WordTune as well, for example. So these are just kind of a small handful of examples. Now, one note I like to point out is that what is kind of making this generative AI even more more like useful for everybody is basically the modality when we need to deal with like multimodal. So for example, like text, you can always be asking question and it comes back response in text, text to text. And that's what essentially ChatGPT came out of. And then now then the Stable Diffusion, Midjourney, these are text to image, or sometimes you can have image to text, or even like image to audio, video to code, for example, or code to video. All of these, they are multimodal is what is going to be the next kind of like the kind of like major type of development in this particular field is to see this multimodal kind of functionality. Now, for example, Google Gemini is actually a multimodal type of model too that supports different models too. So okay, so that's some of the things. And then how about we talk about models, we talk about apps and all of these, and how about the people, right? Just wanted to point out data scientists computer vision engineers, they are the ones that are more subject matter expert. They are concerned with the what. They understand how the data should be. And they essentially gives this kind of subject matter information over to the data engineer and AI engineer and ML ops engineers to help to actually execute and make things happen, essentially. As we all know, if you're a developer, we know if we are developers, we are the one that writes code. But sometimes we don't understand necessarily the context of what we're dealing with. So we rely on the data scientists who know how something should operate and tell us, and then we'll go and implement. So that's, I think, simple enough. As we know, there will be actually new roles that comes up. And to me, there's nothing to worry about. There are, kind of like talks or conversations about, well, with AI, ChatGPT coming out, it's going to take our jobs. But you know what? Seriously, I don't think so. I mean, look at the fact that even, in the early days of Industrial Revolution, people were nervous. It's going to take away the jobs and the factories, everything. You have machines doing the work. But guess what? There are new kinds of work that will pop up that actually will require human beings to do. So there will never be a dull moment that, that we never have anything to do. I think there's always something for us to do. So as such, to me, I feel I can already think of the fact that right now, ChatGPT isn't always right, and that's why I'll talk about hallucinations, for example. So this means we probably are going to need more people to help with validating what's being generated is in fact correct. So that's at least one area I see that we need more kind of quality control people to look over what gets produced. So again, don't worry about it. There will always be jobs. Okay, so now let me kind of go a little faster. I know I've been talking too much. So let's kind of step through a couple of terminologies. First, GPT. That stands for Generative Pre-trained Transformer. So as the name implies, right, it transforms. So what does it transform, right? So essentially, as we kind of look at it again, ChatGPT is really about taking prompts, right? There's some prompts that comes in and it's in the form of natural human language as input. And then what this will be doing, the transformer is going to do is to transform, take what is being asked and essentially do a bunch of punching, right? To kind of do a bunch of pattern matching. They are really called similarity searches. And then it will go look for the answers, for what you're trying to ask like that. So essentially it answers questions for prompts and it produces contents like different kinds. It can be writing an essay, a blog post, writing a new computer program. These are pretty innovative. Never before was it done, right? And this is the first time that you can say, oh, I need a program that can do some sorting and it will generate a couple of routines for you and methods or functions that will do bubble sort, all kinds of sort kind of thing for you as an example. So now let's kind of understand a little bit. GPT essentially started showing up at around 2018. It's basically to Alex Redford's paper on GPT, generative pre-training, in 2018, so roughly 5-6 years ago, of a language model is essentially, that get republished on OpenAI's website. So it described how a generative language model can acquire knowledge and process dependencies unsupervised and then based on pre-training on a large and diverse set of data. So that actually became kind of like the sparkle of what is to come. So then immediately next year, GPT-2 came out. OpenAI released that in 2019. It's basically it gets trained on, more than 9 mission documents. So a bit kind of slightly more documents too that it trained on. And is essentially all of these things, it's essentially is better version of the previous GPT. And now let's kind of move forward to 2022, is just less than 2 years ago, right? Then Stability AI developed Stable Diffusion, is a deep learning text-to-image model. And it's earlier too when I mentioned about these models, and that's when DALL-E and Midjourney kind of came out. So, and then later in 2022, and that's the most famous so far, is ChatGPT that releases like GPT 3.5. So that thing, actually, that's the disruptive thing because it reached 1 million users within only 5 days. And the rest is history. As we can see too, then there are, different vendors, 2023, like last year, we see a lot of vendors that came out, they come out so fast. Right now we're seeing everybody has their companies called .ai or something, right? And so everybody is doing this now. Everybody is thinking of new ways of how can we build apps and make use of this technology. And then in 2023, as you can see, OpenAI releases a beta version, of its browser extension for ChatGPT as well. But then all those two does require, subscription, and also significantly more expensive to say GPT-4 more expensive than GPT 3.5, for example. But they are available now. We can always use it. Okay, so now move on to the next thing, which is NLP, natural language processing. So what is it, right? So it is an interdisciplinary subfield of linguistics and computer science. The concern, too, is to try to process natural language data sets. These data sets came from huge kind of text corpora or speech corpora, too. And then as such too, what it does, it uses like rule-based and probabilistic machine learning approaches to kind of process all of these data too. And then essentially too, that's where all the magic happens, is the LLMs that leveraging on NLP that enables computer to learn from the contents, including contextual like nuances, right? And, of the languages itself. And the idea is to try to draw insights from the documents, not just very straightforward, compute something. It's basically beyond kind of giving you strict answers. It's going to say you can be asking something, it will guess the context around what you're looking for. And that's what gives it even more value, is to be able to draw insight beyond what is just obvious. So, okay, so that was NLP. Essentially, too, then there's LLMs, and that's essentially what developers are working with mostly, right? The large language models. Large language models are a form of what is called, foundation type of machine learning model. Now, the thing is, though, with LLMs, as we all know, it's not for, kind of ordinary citizen, because they are very expensive to train. And it takes not only, because of the huge amount of data, it's not only one GPU or, something like that. We're talking about thousands of GPUs, and also taking a lot of time too, because it's crunching through so much data essentially. And so what it does is that it performs the NLP task. That's the role of large language models. And it generates and classifies text, and then also answer questions in the form of what is called like prompts, right? And just like human being too, it analyzes sentiments and chatbot conversations, all of these things too. And that's where all of the ChatGPT like magic happening is in here in the large language models. So let's take a look conceptually where this stand, right? So earlier we talked about the onion, the simplified like high level kind of model with AI, kind of on the outer abstract level. And then you look kind of a little closer, little hone into that onion is the machine learning that involves unsupervised and supervised and reinforcement learning. And then if you go deeper, that's the neural network layer that deals with, ANN is the artificial neural networks, or CNN is concurrent neural networks, or RNN is recurrent neural network. So all these two, actually is convolutionary neural network, sorry. So CNN and RNN, these are like different like neural networks that are catered for certain specific needs. So recurrent, actually CNN is more kind of more, how can I say, more catered, right, for more doing of the images type of kind of neural network for those type of applications, recognizing image patterns. But RNN is more dealing with like more kind of like a recurrent, and that's what it is. And then for like looping, answering questions like ChatGPT, like more like the languages stuff. Now, the thing is too, is that that's deep learning. As you kind of get a little closer to more specific will be GenAI. That's where it sits now. And then it has the GAN, the GAN, and the VAN, VE. Those are more for image generations. And then there are transformers such as LLMs that are different kind of transformers too. So this sort of like give you a high level understanding of how it, where all the pieces kind of fit together in this, kind of representation of where these conceptual things sits. And as you can see too, it can be a cloud kind of running things. And then there's data science essentially deals with all the data that's supplying all the learning in there. And then essentially LLMs is relying on NLP. It's kind of follows the rule-based kind of training. It's essentially execute those tasks to kind of produce the model too. So I hope that kind of gives you a good sense of where things are. So now you may be asking, well, how can I work with LLMs? And programmers too will interact with the LLMs through using different kinds of libraries. If you're already familiar, or you may have heard of, I believe the most popular one now is LangChain. LangChain is a Python and also has a JavaScript version of it library that's kind of allows you to essentially, connect to LLMs, and also interact now with a lot of data store because a lot of times too, the large language models, they don't have a way to store. It's just a static, kind of giant chunk of model. You just use it, but there's no way it can keep the state, of anything you have done. So you do rely, let's say, on a data store, for example. So these libraries kind of essentially are connectors and connecting different pieces to help you develop your program. So LangChain is one of them. Then there's also Llama Index. Llama Index is kind of similar to LangChain, but I think the specialty with Llama Index is that it deals more with retrieving data, and that's why it's called index. It has a certain way of indexing the data as you are kind of going through using it too. So that's Llama Index, but they kind of do similar things. So depending on your needs, you may want to use one library versus the other. Now, there's also Palm, for example. Palm came out of Google that works with this Vertex AI. And then there's also this one thing called Hugging Face. You may have also be aware of it. And essentially, too, it's sort of like a GitHub, kind of think of it like an AI repository. It's full of different things you can do. People upload their models to it like that. So it's an AI repository. Think of it like that. And also, too, most of the time, too, these are just kind of open source or open way where you can grab all of the models. But also bear in mind, too, these models tends to be quite big, too, most of them. And so it's just so you know, but you can always try to, if you need some models, you can also look up Hugging Face to look for it, too. Okay, so now, as such, I'm a Java champion. I like to also point out, if you're a Java developer, these are some of the Java-based API frameworks. So basically, just wanting to tell you, well, Java is alive and well, still in the AI space, slowly coming along. Java is kind of specific for what it can do too. But the thing is too, right here, I wanted to share out right away. These are some of the open source, and JLlama, the first one, is developed by DataStax, the chief architect, Jake. And so if you're interested you can take a look. And actually, I was playing around, and it supports GPT-2. So I pulled down from Hugging Face a GPT-2 model and playing around with it. You can do that too and follow the examples. If I have time today, I can demonstrate, but I think I may not have enough time to do it. But I'll share with you some information where you can see me demonstrate it on Twitch too. Anyway, so here, then there's also JVector. Is essentially a bit more of a low-level library written in pure Java, and it's kind of handle the vector search that how vector database is using, and specifically with the DataStax Astra database and also Apache Cassandra. And then there's also Java version of LangChain, but it's a completely separate project, not related to the original LangChain. This one is Lang4J is like for Java, right? So that's also another open source project. And then there's also Llama 2 Java, which is a port of the Llama C. So these are just kind of some examples of the Java related framework that you can consider using if you're a Java person. Now, let me then get into vector database and vector search. As I mentioned, what happened is that, the LLMs, large language models, are kind of, as big as it is, as seems like capable as it is, right? It's really about a huge chunk of data, and it's static too. And there's no way it knows, it doesn't remember things. It can't remember all the kind of, state. So then so that's when, for example, like data store will come into place. Now, you can do stuff, obviously, nobody's stopping you to use in-memory type of facility to do it. But as we know, memories too, it's not usually as big as, let's say, a database that can hold even more, more storage, kind of available, kind of more like offline storage than it is with in RAM or something, right? In random access memory. So that's why vector data search or vector search is becoming kind of important too. So let's kind of take a look, So LLMs, or actually, I'm sorry, did I give? Yeah, I skipped a slide. No wonder. Okay, so vector database, what is it, right? So it's essentially a purpose-built database, and specifically too, it serves up vector data type, So what is it, right? It's basically for complex machine learning purposes. It's kind of that purpose-built too. And it relies on vector embeddings. So how can it make it possible to do searches is that all of the data that comes into your database before it needs to be stored, they need to be converted to what is called vector embeddings. Embeddings are essentially, they are numerical representations of the data that's stored in the vector database. So essentially, if I give you an example, you can have like, some string that comes in. So what it does is that it will parse your string and break them up into different words, and each word will get translated to a number. The number is a floating point number, decimal floating point numbers. And so you can have a string, and so they eventually will be stored as an array of floating point numbers that represent that particular phrase. So as you can imagine, there can be many, really petabytes of data, even more of data that kind of contains all of the language sentences, the structure too, inside your database. So they are all becomes like arrays of floating point numbers, and that's how they are. That's how they look like inside a database. Now, why is it so? That's because doing it this way, it will enable and allow the searches to be done using linear algebra, which is a form of, as you know, is math, right? Higher form math, linear algebra that enables you to do vector type of searches. As we all know, if you're a math major too, you may be aware, right, that data can take the form of scalar, which is single dimension of data of all of your numbers, for example, or looking at it like multidimensional. So to represent data that's multidimensional, essentially, we require vector data type. So, okay, so let's kind of take a look at it. So why is it necessary? In this case, vector database too, it also functions as a form of feature engineering. So essentially, too, you are filtering out what is necessary. Those data become necessary, become the core of what is needed to perform your vector searches too. And as such, too, it also requires what is called approximate nearest neighbor, is a technique that allows, data allows the data to be searched, doing these vector searches using this ANN kind of technique to do it. So let's kind of take a look at it, see how it's represented in a graph of two-dimensional graph, So I talk about data is no longer single dimension. What we're usually used to is number one is 1 and 2 and 3. It's pretty linear, right? That if you kind of see the representation. However, with vector data type is that you have to look at where it is, in 2D space in here. So it can be vector 1, this particular vector, it's actually over here, and then vector 2 is over there. Vector 3 is a little bit kind of towards more like X, as the X coordinate kind of like, a little further off, but lower in the Y axis too. So just look at it that way. That's how data is being represented in a two-dimensional normalized kind of vector kind of representation. So it's an embedding model that transforms the text into a vector called an embedding. And this embedding can be however many dimensions, but as such, as we all know, currently OpenAI to the embeddings are 1,536 dimensions. And then there are also, I think, the newer version too, I think, is it 4 that they probably have 16,000, for example, a little bit much higher too. So essentially, too, the number of embeddings kind of shows you how big, that essentially think of it like table, but they are essentially in Astra database, we call them kind of a collection. So it kind of dictates like how big it can hold all of the information in there. Now, as you can see, similarity in here too, we're trying to describe V1, it will be more similar to V2 than V3 in here because they are closer. The distance between the two is closer. That's how we determine, it's a mathematical formula to determine how close. If V1 is a search string, and we know that V2 will be closer to V1 than it is with V3. So that's how it's being represented. Now, this is another example, but we're using a little bit of the actual kind of some real word to describe, V1, for example, you're looking for a cat, then you want to look for something that's closer to a cat, then dog is kind of on this two-dimensional graph. It looks closer to the cat because they are both animals. So then as such too, if you search like that, maybe you come back, given if it's cat near the cat is a dog, then the dog will be returned as opposed to a house, because house they're kind of just not the same category of items in here. So yeah. So essentially, too, over here on the right side, we're describing the dimensions are the result of the LLM training, and that's what it is. So. Okay, so here too, I won't kind of get into too deep about it, but essentially too, there are also like different layers of all of these characteristics too, of, as layer 0 or 1 or 2 in here, then we can kind of determine, how close, a search result can be as such. So as such too, so vector, that's why, this is how kind of vector data is being kind of stored, in a database, and also is important, how good a vector database search the queries is too. It needs to be super fast, of course. And so that is very important. And there are different kinds of techniques and algorithms too. And there are kind of essentially built-in algorithms for like nearest neighbors embeddings, right? For example, a more common one that started off will be called HNSW, like hierarchical network. Okay, this one I kind of exactly forgot. Just snap cannot remember. But anyway, trust me, HNSF or HNSW is this particular technique, right? Of doing retrieval of data, and that's actually used by Elasticsearch too. And also, even before, they're a lot more commonly used. However, they realize there's also a bit of a not the most efficient. So then there are new techniques being developed. For example, this one JVector is actually developed by the technical co-founder at DataStax. His name is Jonathan Ellis. So he developed this JVector, which is a pure Java library too. And that one is being used in Cassandra as well as Astra database, and also like very, very fast too. So that's just to let you know. Now, let's kind of get into the next line. Vectors are basically a new type of data supported in established databases. And so, for example, DataStax Astra DB is vector database. And there's also, for example, Pinecone, Weaviate, PG Vector is from Postgres, and also Milvus. Now, these again are just small handfuls of all of the databases. There are other ones too. So just wanting to kind of point out to you. Okay, so let's kind of also kind of go through again what are vector embeddings being used for, right? So essentially, they are used for similarity searches where the results are ranked by relevance to some query string, right? And we saw like in the two-dimensional space how, different data is being represented. You want to look for the closest distance to where you are trying to do the search for, and that's what will get returned, And a lot of times too, when you do query, you can also specify how many I want back, right? So then you can determine, from there, which one is the closest to you. So as such too, vector searches are non-deterministic too. It's not, can be a little fussy in that sense. So just be aware of that. So vector embeddings are basically used for searches. And also you can do clustering with that, as well as like recommendations in shopping, kind of shopping recommendations, for example, because items are kind of related. Text strings can be kind of are being recommended, right? What is closest to which, kind of like that. As well as, vector embeddings can be used for anomaly detection too. So, and as you can see, and this kind of helps with it too. And then also, if you kind of dealing with math, right, similarity distributions, you can analyze it, then you can kind of figure out the diversity measurement in there. And then also with classification, where text strings are classified by their most similar label too. So yeah, so these are just some of the usages for vector embeddings beyond just the similarity searches. Okay, so just a word to point out is that there's also traditional database, that can be used in AI. So nothing is impossible. However, traditional database is not built, to handle multidimensional data. They are mostly for single dimension. So then, as such too, then it's not capable of handling complex data that's kind of handled by vector, for example, right? They are not multi-dimensions. So in that sense, you can still use traditional database, but maybe you will need to do a lot of translation in the processing part in order to be able to handle the multi-dimensionality of the data itself. So as a result, because of that, you can expect traditional database to be extremely slow if you decide to choose that route. So we like to recommend that don't use traditional relational database, just basically look into like vector database that can help you to do searches much faster. So as such too, yes, so that's what I've explained over here. So just kind of keep that in mind if you're kind of shopping around. And this one too, just give you an idea of where vector database can sit, essentially in a, diagram of a generative AI type of systems, right? So as such, you can have user input as a prompt, asking some question, it gets the data, into it. And essentially too, it's called what is called embedding service. You will need to convert the data into embeddings, right? Different vector embeddings, and dealing with the vector data, you can augment essentially to what comes from the LLM, right? LLM is already pre-trained, but you can have different data that's being supplied on the fly or kind of being fed in, from external data source that, are kind of being fed in simply because the LLM got trained a year ago, data from a year ago. So between last year, the cutoff, and now, that set of data is not already in the LLM. So you want to supplement, that knowledge base, to the LLM that where data is missing. So you can actually be using this and supply this additional set of data to it, and what is called retrieval augmented pattern type of way of doing things, retrieving those, and essentially to store them in the database, the embeddings being stored. And then when you need to ask questions and you send the prompts over to the LLM will figure out and let it do its magic, figure out the answers, and then send you back. Essentially, it send back some data. And then basically too, then it can be doing logging and prompt logging. All of these two can be stored into your database itself, because it may be important that, for example, you have chat applications like chatbot, and after chatting, that data needs to be stored somewhere, so you can clearly be storing that. The chat history can be stored in the database. So this is just an example kind of showing you how a typical ChatGPT type of apps can be looked at from a conceptual point of view. Okay, so now let me, I think I have some time. So let me really quickly then going into showing you the Astra database from DataStax. So as such, I've shared with you the links too. So let's go over here, and I have the link in the the slides there. So okay, so basically, too, you can take a look into here. And DataStax offers like $25 per month for free tier access. And it's only asked for your first name, last name, and email. There's no need for credit card, which is kind of nice. Now, in my case, I've already signed one up. So I just simply sign in with my Google account. And then it should come up very soon. Okay, and yeah. Okay, here we go. So now you can see, right? You sign in. As you can see, you can kind of look into database. I don't have any data tables or collections or database set up yet. So that's what we're going to do. We do a create vector database, and you can kind of do a serverless vector and create a database. Let's say we call it E2E networks database like that. And then we want provider. How about Google Cloud? And then I'm in US, so I do US East, and then create the database. So as you can see too, there's also non-vector database that you can use too. But if you want to get a quick test drive, this is what you can do, right? So it will take a few minutes. And once it is created too, as you can see, you notice too, there's database ID information in here. And then while it is doing, I can go to Data Explorer. So it will explain to you is that is a new public feature, preview feature too. So it's not like all finalized, but it can be used. So you can kind of continue, but I think the database is still initializing. Sometimes it goes faster than others, but sometimes I don't know, maybe it's doing maintenance right now. But as such too, as you can kind of look around too, with this interface is quite easy. You can also create different organization, right? You can be doing different things, and essentially you can have different projects and create different organizations to house your different database too. Okay, so here we go. E2E networks. Okay, this one is still being initializing. Okay, but in the meantime, let's kind of go back to our home page. In the meantime, I just wanted to show you like view docs too. So if you go to view docs, and because you want to start to play around with it, right? So docs here would have like quick start. And the quick start will also explain to you some of these vector database thing, and then how do you create one? You can kind of step through this. And then also, it explains to you how can you get your tokens and all, typical thing these days is you always need security tokens to do your stuff. And also too, you can run Python client or TypeScript or Java too in here. So all these are being kind of laid out for you. So in the meantime, let's kind of try to get back to my, okay, this one actually is here. Okay. And let me kind of go back to here. Let's see. Hopefully this is, it's still, okay, great. So here we go. So now you can take a look, and this is the database, and the database endpoint application tokens. You can generate the token in here, and the region is essentially US East in here. So what we can do too, go to Data Explorer, and we can what is being called is that the namespace, there's a default key space. If you don't create one, it's essentially a namespace, but you can also create different kind of namespaces that essentially think of them like containers, separate out all of your collections. Collections are essentially like tables for a database, but collections for vector database. So you can actually do a create collection in here, and then also, or you can create an empty collection too, or create a sample collection as well. So let's take a look. How about create a sample collection? So over here, essentially too, they will also populate your data with some kind of sample data as well. I don't know why tonight is taking a bit longer, because usually it doesn't take too long, so I apologize. But in the meantime, let's kind of take a look. You can just do a create collection. So let's say we call it E2E collection. Oops. Oh, I think it's loading right now. Okay. All right. Okay. So it actually comes back. So, okay, let's kind of go back to our original plan. Just create a sample. So this sample is called movie review. So it contains a lot of records that are movie reviews. So you can kind of take a look. I think it's already loading all of the data sets for you too. So you can get, your connection details while it is running. So this is pretty cool. It kind of gives you example of how can you run a Python client against it, for example, do just simple connection in here, or TypeScript client. So it's pretty cool. Or if you're Java, you can also write Java code to kind of essentially get your token as well as doing connection to it too. So, okay. So while this is loading, actually, I think I was given like 45 minutes. So I decide, let me not kind of continue, because this is pretty self-explanatory. So I would like to invite you to sign up for this account and give it a test drive. Again, doesn't cost you anything to use it too. So, actually, now it kind of comes back, right? So it also will describe, a lot of the details for you. So and you can kind of continue. Oh, here we go. So now you can see all of the data gets loaded. And I just wanted to quickly show you a vector, for example, a vector, kind of tape, like a example data. Remember I told you about this one. You can do a copy, and then you can kind of, well, actually, you know what? The similarity, okay, JSON, but you can look at the table or the JSON too. JSON format might be able to show you a little bit more. Here we go. So as you can see, right, my JSON data will show my data has a field called ID, and then title, review ID, creation date, critic name, original score, review date, blah, 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 all these. And as you can see, you want to take a look at the vector here, vector column, as you can see, right? Oh, yeah. Okay, here we go. You can kind of see it's an array of floating point numbers. So as you can see, it can contain a lot of things. So essentially, too, they contain a whole paragraphs of data in it. So I just want to kind of quickly show you that. But let me then go back to the presentation because also I realize time is running short. So, okay, so let me then close off this discussion by discussing the benefits, right? Well, as such, we all can already take a look at it. It's much like ask and you shall receive. So it's much like all you need to do, just ask, but make sure you ask the right questions and you should be able to get your answers back. And so the nice thing is that work is being done for you by the bot is much faster. So that's a good thing. However, the challenges are there too. So I brought up about hallucinations. Now, the thing is too, LLMs are, even though as big as they are limited too. They don't contain everything, right? Yeah, they do contain a lot of things, but not everything. So there's always that gap in there. And then if it doesn't know an answer, it could come back with the wrong answers. And that's where the danger is, right? And then another thing too is that it can have ethical concerns. Sometimes too, we can have misuse, but without kind of being intentional. So for all these kind of things, we have to be careful too. And there's currently no kind of official, like, overseeing government, or some kind of overseeing agency to look over to make sure what is being done is correct. Because there have been people saying that, well, it can actually design bombs, or something, right? Doing something really malicious too. So just be very careful with that and also be responsible too for what you are using it for. Another kind of shortcoming is that, as I mentioned, LLM, for example, even GPT 3.5, it got data from 2021. Now, we are now in 2024. So if you're using GPT 3.5, it doesn't have data in 2022 and 2023. So in that case, what can you do? So that's when we may want to consider using a design pattern called RAG, retrieval augmented generation, like in that one diagram I show you. Use that pattern for doing retrieval as well as doing kind of like a generating, data responses based on, whatever you have retrieved. That kind of helps fill in the gap for what LLMs kind of don't have. So those are the kind of things that please be aware, but there are other issues too. So just be aware. And so now comes to the end of this talk. Just wanted to share with you the resources if you are interested. This is the slide deck here. So if you want to take a picture of the QR code or get the bit.ly link, you'll be able to get to this slide deck, and then you can kind of look up other information in here. Okay, now if you miss it, don't worry about it, because I think this will be recorded, so you'll be able to play back and kind of get to this page or ask the organizers for the slide deck, which I'll be sharing with them. Okay, so here are just resources from DataStax if you're interested. And the one in the middle here, the short kind of bit.ly kind of dtsx.io link, is the bit.ly link that you can actually use to kind of create your free tier DataStax Astra database account, which I just demoed. And also, this is the main one. I'd like to invite you to follow my stream, my Twitch stream. And I usually do it Wednesday, Thursday, or Friday afternoon, depending on my time. But that's in US Central Time if you like to join. Otherwise, you can always look up on me. There's a recording being saved on my Twitch for 60 days. Or if you go to my YouTube, you can also go to my channel. The stream will also go there as well. And then with that, I want to thank you so much. And I think I already took up almost an hour. So I hope I have enough time to answer if you have any questions. So thank you.
Thank you so much, Mary. We'll be taking questions. If anyone has any questions, you all can just put it down in the question answer area, and I will pick it up for Mary to answer.
Okay. Yeah. I don't notice. Is it on the Q&A box? Right? I just opened that up, but there's no question right now.
Questions so far, yeah.
Okay.
We'll still give them a little time just in case they have any questions.
Sure. Yeah.
During this time, I'm hoping that y'all could also fill up our feedback form that you will get at the end of when you leave the Zoom call. Um, so Mary, it doesn't seem like they have a lot of questions for you.
Okay,
Um,
no problem. Yeah. Maybe I like to invite attendees, maybe even if they're watching this on demand, that I should be in Bangalore for GITS again this year for the Developer Summit. So yeah, in April. So yeah, and I hope to meet some of the folks too. Yeah.
oh, that sounds very interesting, Mary. We should catch up. If you could just let us know whenever you're going to be here.
Sure.
In April, we should.
In April. Yeah.
Yeah.
Yeah. Great. Yeah. Thank you.
So I think that's all for today. Thank you all for joining us, and thank you so much, Mary, for giving us this talk. We are very, very obliged. Uh, I hope we have future opportunities to get along and do many
Thank,
more such webinars in the future as well.
thank
Thank
you.
you once again. Uh,
Thank you.